Okay, now we can sketch the asymptotes by using the frequency that we get from the previous calculation. Okay, so take a look at this formula. Okay, this formula, we can say that it is approximate analysis equation. Okay, for this one we get the asymptote. Okay, remember what is asymptote? Asymptote is a straight line that has a slope equal to 20 dB per decade. Okay, so we have to find 2 points, okay, to draw a straight line, okay, which is we get from this. Okay, so in this equation we see there is a F1. F1 is actually the FLE, FLC, and FLS, and another F. This F is actually this value. Okay, you can see for this value. Okay, can you see why the frequency value for the FLE here is different from the FLC and FLS? Here is 10, 100, 1, 10, 0.1, and 1. Okay, I will explain a little bit here. Okay, the FLE now is 327. Okay, and FLC is 25.68 Hertz. FLS is 6.86 Hertz. Okay, to draw the asymptotes for the low frequency response, it should be like this. It facing to another side here, so we call this, it has slope here, which is negative 20 dB per decade. Okay, the slope is here like this, and so during this time, okay, at this point, okay, to draw the asymptote, this point is the actual frequency that we get if this is the FLE. Okay, this point is equal to 327 Hertz. Okay, so to get another point here and here, so we take a decade in front of this 327 Hertz, which is somewhere here. Okay, so 327 is in the range is from 100 to 1000 Hertz. Okay, for 327, right? So we take another decade here in front here. So let's say this is from 100 to 1000. So we take another decade in front of the 100 is from 10 to 100. Okay, so we get another one is 10 to 100. Then for the 10 here, like it can become another one is 10 to 0 to 0.1 to 10. That's why this point, you see, is at 10 and 100 here, 10 and 100. Okay, because of this. Okay, let's say for another example. Okay, we go to another example. For the FLC is 25.6 Hertz. Okay, so 25.6 25.68 Hertz is at range 10 to 100 Hertz. Okay, so this is 25.68 Hertz, the actual value for FLC. Okay, then to get another point here, it is actually, we take 10 decade, so 25.68 is at 10 to 100 Hertz. Okay, so here is 10 and this is 0. This is 1 to 10. Okay, 1 to 10, the range. Okay, so we take another point in front of it, so we get 1 and 10. Okay, and take a look for another example for the FLS. The FLS is 6.86 Hertz. 6.86 Hertz. So it is in this range from 1 to 10 Hertz. So this is the actual value. So 6.86 Hertz from here. And then another point here. Okay, 6.86 is at 1 to 10 Hertz. So we take another decade in front of its value, so it becomes 0.1 to 1. You see, 0.1 to 1. Okay, this is because its range for the frequency is different. That's why I take a different range for the for these 2 points. Okay, now once you set this value, then you just calculate directly using this equation. So by using this formula, and this formula, you get this value. Okay, after that, plot these 2 points on the graph. Okay, see, this is